Alright, so we're going to go over factoring monomials today. Okay, so we've done this before. It should be about the same. There might be a little few things that we're kind of adding, but overall, okay, it should be a review for you. So if we look at this first one, it says, given 4 times 5 to the second power, what would your first steps be mathematically? Okay, so we're just going to answer, and then it says, what can you model, and can you model it in a picture? So we're just going to answer this first question first. So what would your first steps be mathematically? So if we look, we know, and you've heard of it since junior high, okay, at least, okay, something called PEMDAS. All right, so the P represents what? Parentheses. E is exponents, and multiplication. D is division. A is addition, and S is subtraction. Okay, so we want to know, we're going to use this to help us know what we have to do first. So the first thing is parentheses. Do I have any parentheses in that problem? No, so I'm going to move on to the next one. So I go to E for exponents. Do we have any exponents? Yes, we do. Okay, we have 5 to the second power. So our first step is going to do 5 to the second power. Now, 5 to the second power. What that means is you are doing 5 times 5. You're doing 5 twice. Okay. What it does not mean, I'm going to do it in red because it's what you do not do. So 5 times 2 is what you are not going to do. Okay, that would be wrong. So you're always going to do 5 times 5. Well, 5 times 5 is 25. So now that we've done that, our second step is then to take our 4 and now multiply it to that 25, which gives us 100. Okay, so now that we've solved it mathematically, they want to know, can you use a model? Okay, now our models is going to be like blocks. Okay, can we use blocks to model it? So we want to do 5 to the second power, multiplying it by 4. Okay, so we're going to have our 5 to the second power, and we're going to have it 4 times. That's what that's saying. So I'm going to take 5 times second power. I'm going to have another 5 to the second power, another one, and another one. Okay. You can write it separated like this. You can write it in one big block like this. It does not matter if you're modeling it or they're showing you a picture to model it. You just want it so that you have this number, so the first number, which is your 4. You want to have 4 blocks, and then this second part is what's going to go in each block. Okay, so that's how we model these things in a picture or in our blocks. So number 2 says, given the expression 32x plus 80x squared, what is the GCF? So the GCF, okay, is just going to be, what do they have in common? So to do that, we're going to start with our 32, just our first number, and we're going to write all of its factors. So its factors are, well, we have 1 and 32. What else? 2 and 16. We have 4 and 8. Are there any more? Okay, no. So now we're going to move to our second number. Our second number is 80. So again, we have 1 and 80. What's next? 2 and 40. Then we have 4 and 20. What else? 5 and what? 14? No, 16. It's not writing. Okay, here we go. 16. All right. What else do we have? Do we have, will 6 go into it? No. What about 7? Will 7 go into it? No. What about 8? Okay, so we have 8 and 10. Is that all? Yes. Alright, so then we're going to go and we're going to do our x's. So the first one is just an x. Okay, so just one x. And then x squared means I have 2 x's. So how many x's do they have in common? Just the one. Okay, now if we go to our numbers, what factors do they have in common? Let's just circle all of our factors. So they have in common a 1, they have in common a 2, they have in common a 4, and they have in common an 8. Okay, what's the highest number that we circled? An 8. So that's going to be our GCF. So we have 8, and then we only had one x in common. Now remember, when we're looking at our x values for our GCF, you can always take your lowest exponent. So between x and x squared, your lowest exponent is just that x. Okay, so instead of having to write that all out. Alright, now for number 3, so we're finding the GCF and we're factoring this expression. So remember that whenever we are finding GCF and factoring of a monomial and it tells us GCF and factor, we do our one long box. Okay, and so we're going to put what they give us into our box. So we're going to put our 9x squared and our 12x inside the box. Now we have to figure out what our GCF is. Now remember that your GCF, so down here is where your GCF is going to be, and up here is your factor. So if I take 9, its factors, we can't see that. If I take 9, its factors are 1 and 9 and 3 and 3. With 12, its factors are 1 and 12, 2 and 6, 3 and 4. So what numbers do they have in common? So when we circle them, we see that they have 1 in common, they have 3 in common. So your highest number is going to be your 3. And then your lowest exponent between your x's are just an x. So now we're going to fill out the top. So 3 times what up top gives you 9. 3. If I have one x, but I see I need 2 of them, I need one more x. Then 3 times what is 12? 4. I have one x, I only need one x, so do I write one? No. So my final is 3x, the left side, parentheses, what's up top. Okay. Number 4, so what is the expanded form of the factored expression 6x parentheses 4x plus 1? And we want to know what property that we use. So all we're doing on this is we're just going backwards. So we're still going to have our one long box, but now they give us our GCF of 6x, and they give us what goes on top, which is 4x and 1. Okay, remember that the expanded form is always what goes inside. So the expanded form is what's going on the inside. So that's why we know that if we're looking for the expanded form, we're looking for the inside. So we just multiply. So what is 6 times 4? 24. I have one x, I have another x, so I have a total of x squared. And then 6 times 1 is 6. I have one x, I don't have any on top, so I just have an x. So we can rewrite it, so we include our addition sign, so we have 24x squared plus 6x. Okay. Number 5, so given the expression 40x squared plus 16x, what is the GCF in 2 addends? So all this is saying, this right here, is just telling you what's your factor, what's on top. Okay, that's a way that they're going to ask you later on, especially when you do Imagine Math, so we just kind of want you to understand what that means. So all it's saying is, again, they're giving you what, they give you your expanded form, they give you what goes on the inside, and they want to know, okay, well, what's your GCF and what goes on top? So you can rewrite, you can come down here and you can write out your factors, or you can know just what do they have in common. Okay, so your greatest common factor is 8. And then they both, your lowest exponent is just an x. Okay, so 8 times what is 40? 5. We have 1x, we need 2, so we need 1 more x. 8 times what is 16? 2. I have 1x, I only need 1x, so I leave it. So I can write it as my GCF, which is 8x, parentheses, what's on top, which is my factor, so 5x plus 2. Okay. Number 6, so factor the following expression completely. So 4x squared plus 2x, they want you to factor it, which is just going to be our one long box. And what they give us goes on the inside. So between 4 and 2, what is your GCF? What do they both have in common? They both have a 2. So if I have an x squared and an x, my lowest exponent is just x. So now I go up top and I figure out what I multiply by. So 2 times what is 4? 2. I have 1x, but I need 2, so I need how many more? Just 1. 2 times what is 2? 1. I have 1x, and I just need 1 more x over here. I need 1 x over there, so do I need any more? No. So I write it as my GCF, my first parentheses, what's on top, which is my factor inside. Okay. Number 7, so factor the following expression completely, 12x minus 9. So again, they want us to factor. So we're going to do our one long box and put our 12x minus 9. Alright, so we're going to figure out our GCF. So if I look at 12 and 9, okay, when we did this one before, so what number do they have in common? The 3. Now, do both of these boxes, so here's an x, does this box have an x? No, so can we write it in front? No. Okay, so our GCF would only be a 3 here. They both have to have the variable for you to be able to write it. So now we're going to go and we're going to work. And we're going to figure out the top. So we have 3 times what on top equals 12. Well, 3 times 4 is 12. Okay, I have an x in this box. I still need that x, so I'm just going to bring it up because I have none over here on the left-hand side. Okay, then I have 3 times what on top is negative 9. Negative 3. I have no x inside. I have no x on the left, so we're good. So I just write my GCF, parentheses, what's on top, which is 4x minus 3 as my answer. Okay.